Hi, class. So sorry about for those of you that couldn't get into the Zoom call last night. I had some problems, technical difficulties with two different Zoom accounts, so they should be all taken care of for next week. What I wanted to do, though, was show you some of the things that I'm seeing and explain the different weather maps and how we go about forecasting the weather. So you look outside and you see what's going on outside with clouds, and they'll be at different heights, and temperatures will change if you climb up a mountain. Well, if I'm trying to show that information, what I have to do is show it at different layers. So what you're looking at here is not just a blob of beautiful colors, or maybe not beautiful colors, that have been thrown up on the screen, but a forecast model. And don't worry, I'm going to explain it to you because I know it's a little complicated. So what I want to do is start right here so you can see that this is the United States. So going down the west coast of Canada, the United States, here's California here. So the base map's not going to change down to the Baja. And then you've got the Gulf here, Florida, and coming up the East Coast. So I know that there's a lot going on this map, so hopefully that helps you to get started. So what I wanted to show you is what's going on right now in the weather. And I know we've got a lot of East Coasters, and you're complaining that the temperatures are really cold. And the reason is because we have this deep low pressure system. And the reason why I say it's deep is, one, on these maps, areas that have the same, in this case, this would be isobars, barometric pressure, we connect those areas together with a line. And so these are just like what you learned earlier about topographic maps. The weather, the atmosphere has similar characteristics where we have mounds of big, cold, high pressure system. We have a low pressure system, but they differ in their position based on where you are at the surface or up above. And how they interplay with one another determines if they're going to strengthen or not. But one thing that you can see, and I kind of started showing you this last week, is that you end up with, this is up at about 35,000 feet. Let's see if we'll stay anchored there. At 35,000 feet, we have had a ridge, a big mound of air sitting over the west coast. And we have the same thing that happens that like at the beach. If you have a really big wave, you're going to have right next to the top of the peak of that wave a really deep trough. And so in the weather pattern, it has waves to it. And if you have a really strong ridge, you can't have another really strong ridge next to it. You're going to have a deep trough. So that's what we're seeing in the United States. And it's been the pattern for a while, where we have this strong ridge over the west, it goes up high, and then a deep basin trough over the east. And so what has been happening is the storms have been coming in off the Pacific, really strong storms, but they're forced to go up and over the top of this ridge, and then they dive down into the East Coast, bringing in the colder air. So watch what happens over the next few days. This is stepping forward by about 6 hours at a time, not by about, but exactly 6 hours at a time. And you can see that the ridge is yielding a little bit. It isn't so much yielding as what happens, let's see if we can anchor there, is that we have the storms that are coming in over the top of the ridge are making it retrograde, go backwards. And so some of that cold air is going to start pouring in down into Southern California this weekend. And meanwhile, in Florida, it pops back up so it's not as cold. So let me show you another layer here. This is at what's called 850 millibars, about 1,500 meters, not millimeters, above the ground. And what we show on this map is we've found that we can determine temperatures very well from this map. Sorry, I want to be able to anchor it and then move my cursor, but it doesn't always like to do that. So the blue on here is cold air, and then the green and the pink is really cold air. So see that cold air up in the Arctic? So I'm going to move this ahead. And you can see that the cold air starts to dip way down into the Gulf and off along onto the East Coast. But now on the West Coast, some of that is starting to dive down and go further west. And eventually this cold air is going to lift out of the east. But look at that cold air that pours down out of the Arctic. Let's see if it'll stay there so I can... and down into Minnesota and into the Great Lakes. Canada is going to be really blasted cold before this all moves out. The other thing that we look at is at 700 millibars, we look at the moisture. So green on this map is moisture, and we don't have a whole lot of moisture with any of these systems because they're coming basically straight down out of Canada. We've got some, but not, it's quite limited. I can tell you when it's wet, we're going to see dark, dark, dark green. The other layer that we look at is way up into the jet stream, which is about 35,000 feet. So the level of commercial jetliners are at. And here, this is a representation of the winds. So light blue, light winds, darker blue, stronger to the purple. That would be the core, the jet axis, right in there. And you can see that it is out ahead of that system. So because on the East Coast the jet is further to the east of the system, it's not going to pull it out very quickly. So it's kind of slow going. It finally does, and then we've got a jet core coming in right here. And this is going to help to break down this ridge and help this storm get up and over it and start to retrograde back towards west. So we got some changes starting next week. Coming to the middle of next week, it'll warm up a little bit on the East Coast, fortunately, for those of you down in Florida. But it's going to be cooling down here in the west, which we need, because right now we have forecast high 84 degrees, my place 90 in Los Angeles. And you might immediately say, well, global warming. Well, no, it's just like a seesaw. If one place gets really, really cold, the other place has got to get really, really warm. So this is part of just normal weather conditions, but you will always hear people starting to, when it's really cold, start really warm, blame everything on global warming. So this is typical, though on the extreme of typical. So hope that helps you with understanding a little bit more about the weather and what's going on for us right now. If you've got any questions, let me know. If you've got test questions, just you'll start to see the feedback and be able to check your test questions. If there was anything that was wrong, just let me know and I'll be able to help you out. Thanks so much, you guys.